Okay, so let us start the first class on this design of structures 2. First of all, at the very beginning, I will share with you this is the syllabus. This is the syllabus of this paper, theory paper, design of structures 2. I think you are getting this syllabus over the screen. So this is the syllabus for this particular paper as per our departmental decision. This is the syllabus. Now, actually, SM sir will take a part of that and I will take another part. So you know that actually for every paper, we generally divide the subject into different modules. And you know, for the NBA guideline, we have to prepare some course outcome from each of the modules. So I am telling at this moment, it may change, it may be changed, but please consider this particular distribution at this moment. This is module 1, module 2 and module 3. It will be taken by SM sir. Okay, Professor Sharoj Mondal sir. So this particular part he will take. And in my classes, I will try to complete this particular portion. That means module 4, module 5 and module 6. In the module 4, there will be design of beams and plated beams, purlin, etc. In the module 5, design of column, compound column. Then module 6, design of column base connection and foundation, etc. Okay, so these are the 6 modules of this design of structures class. We will take it one by one. Different topics are there. We will discuss. We'll try to complete all the topics that are there in the syllabus. So these are the course outcomes of these 6 modules. Okay. Obviously, you may tell that this is not required at this moment, but still I'm sharing this one. Actually, we should share this one at the beginning of the semester. So as it is ready, so we are sharing this one with you. Okay. So we will start with the designing of the beam today. Actually, I will take this part. So I will start with designing of the beam. Beam means obviously it's a steel beam. Now, before telling anything regarding the designing of beam, etc., we should discuss some basic points that is related to the designing of structures 2. If you just look at the syllabus or different modules of the syllabus of the design of structure 2, you will see that this is the paper, design paper, where basically we will discuss the procedure of designing of the steel structures. Okay. In our earlier curriculum, the name of the paper was design of metal structure. Actually, it is not in general topic that is the design of metal structure. It is basically the design of steel structure. Though here it is introduction of metal structure. Here metal means not any other metal. It is basically steel. Now, different type of steel structures you have seen. For example, say very common steel structure is, say, the factory shed. There may be some bridges. There may be some towers. Okay, these are the common steel structures. Other than this one, nowadays the building frames are also being constructed with the steel sections. So steel is also one important. It is called the structural steel. It is called the structural steel. It is not the steel reinforcement that you have considered in your reinforced concrete design. It is the structural steel, and there in this type of structure, basically these are constructed by connecting number of steel sections. Okay, so if you want to construct one, say one transmission tower, so there will be number of steel members, structural steel members, that will be connected to each other by different connection systems. You are getting here that the connections may be of riveted connection. This may be the bolted connection. This may be the welded connections. So connection is very important part of the design in the designing of the steel structure. So designing of the steel structure obviously will include not only include the designing of different steel members, as well as it will include the designing of the connections. Unless otherwise you do the connection properly, then the structure will fail at the location of the connections. So we should design the steel structure in such a way there should not be any failure of the structural members, as well as there should not be any failure of the connections. Okay, so in case of RC structures, we have designed the RC beams, RC frames, columns, say RC slab, etc. We have not considered the designing of the joints. Okay, some standard reinforcement detailing we should follow for the reinforced concrete frame structure. So that guideline is there, but we have not individually designed the connections. For example, beam column connection, etc., or slab beam connection, etc. But in this case, as it is made by, it is fabricated by connecting number of different steel sections. So obviously, the connection is very important. So you have to design when you will do it professionally, or say when you will do it even for the academic purpose. See, you are designing a factory shed. Not only you have to design the members only, you have to design the connections also. The connection may be of different types, one by one, that will be discussed in this class. So at this moment, just I am giving you the basic idea that in the designing of the steel structure, which is basically the topic of this discussion of the designing of the structures 2 part. So here, designing of the steel structure, design process of the steel structure will be discussed. So it will be basically having the design procedure for the members as well as the design procedure for the connection. Okay, so both of these two will be discussed. And also there are different points, that is the calculation of the loads. You have considered some calculation of load for the concrete structure. Here also we will do the calculation for the loads, but there will be some other type of the loads that will come over only the steel structure, that will not come over the concrete structure. Okay, so those things also will be discussed in this class, in different classes of this paper, on this paper. Okay, so I am not telling anything in this particular part. That means this will be taken by essential. I will directly start with designing of the beams. Okay. Now, before starting the actual description, actual design process, etc., I am telling you, please note it down, that you will require different IS codes, for the purpose of steel design. So the basic code, the most basic code for the designing of the steel construction is IS 800-2007. So this code you will require at every step of doing the designing of steel structure. You will require IS 800-2007. Just like IS 456, you have seen that the reinforced concrete structural component cannot be designed following the guideline, without following the guideline of IS 456. Here also, at every step of designing the steel structure, you will require the help of this particular IS code, IS 800-2007. So this is the code. I will tell you during my discussion, but at this moment I am telling that you have to keep this copy. Obviously, soft copy may help you at this moment, but when you will do it professionally, or say when you will appear in the examination in the offline mode, then you have to bring the hard copy of this document in the examination hall. We allow the use of this IS code in the examination hall, because you have to follow the guideline given in this particular IS code for the purpose of designing of the steel structure. Now, another point I will tell at this moment, you must remember this one, that other than this IS 800, there will be some other IS codes, okay, that you should consider. Now, just after this IS 800, I am mentioning the name of this particular handbook. You have seen SP16 is one handbook where the different design data that are given for the designing of the reinforced concrete structure. Okay, but in case of steel structure, obviously there will be number of SP, that means the special publications of Bureau of Indian Standards, that we may have to follow. But the most basic one with which we will start our discussion is this particular handbook. This is the handbook for structural engineers. That means Here basically you will get the structural steel sections. It has also different parts, but SP6-1, that is the first part of SP6, that we will use for the purpose of designing of the steel structure. So when you will start designing the steel structure, you must have the copy of this code. This is IS 800 2007, and you must have the copy of this handbook for structural engineers. Now you may ask, what is the content of this handbook? Okay, it is not like the handbook SP16. Okay, SP16 will give you some data regarding the design outputs, etc. Okay, if you know the bending moment, then ultimate moment, then what will be the reinforcement percentage required, that kind of things you have got from SP16. But SP6 is a particular handbook where you will get the properties of the structural steel sections. So let me show you some of the pages of this book, of this handbook. Okay, so this is the handbook. You just look at the contents page. Okay, you will see that there are different structural shapes and other steel sections: roll steel section, roll steel channel sections. There's a beam, roll steel beams, roll steel channels, roll steel equal angle section, unequal angle section, etc., etc. So these are the different sections for which these are the standard sections. Please remember, these are the standard sections, and for these standard sections, what are the properties, cross-sectional properties that are given in this particular handbook. So let me show you few pages of this handbook, then you will be able to understand. For example, say in case of steel construction, we use some standard sections. Okay, standard roll steel sections. Now the standard roll steel sections, why it's called standard? Because its cross-sectional property, cross-sectional dimension, cross-sectional parameters are fixed, whether it is being prepared by manufactured by company 1 or company 2, there will not be any change in the cross-sectional dimension, etc. So when we are telling that, for example, say I am telling it is ISLB 400. So ISLB 400, okay, just consider this one. This ISLB 400, one of the sections. So here, what should be its weight per meter? That is given in the first column of this table. Then what should be its cross-sectional area? Okay, it will be a basically one-dimensional member. It will be basically a one-dimensional member. Okay, just like the beam, reinforced concrete beam you have seen, you have designed, just like that. But the cross-sectional shape is not rectangular. Cross-sectional shape is of this type. So this is called the roll steel beam sections. Actually, it is called the I sections. Now, for this I section, for example, for any particular I section, all these parameters are fixed. That means these are standard. So if you consider ISLB 400, its weight per meter, length, it is 56.9. Its cross-sectional area is given here 72.40 centimeters square. Then the depth of the section is given as 400. That means this is the overall depth H, that is 400. Okay. Then it is the flange width of the flange. You know, probably, still I'm telling, if you consider an I section like this one, then these two horizontal part, what is shown in this figure, that is basically the flange. This particular part is called flange, and this vertical component or part, that is called the wave. So this is the upper flange, this is the lower flange, and this is the wave part. Okay. Now, if you just consider this is a cross-sectional view, obviously it will have a specific length. So length is not standard. Length may be different from company to company, but their manufacturing company to manufacturing company will vary. But the cross-sectional properties are fixed. Okay. So cross-sectional properties are fixed means cross-sectional dimensions are fixed, not only the properties. What any cross-section, for example, the ISJB 150. These are the cross-sectional properties. Depth of section H means this one. Okay, I am showing this one for this particular section. Width of the flange means this B. This B is called the width of the flange. So width of the flange B has 50 millimeter. Thickness of the flange. The flange must have one particular thickness. So the average thickness. If you look at this figure carefully, then you will see that there will be a variation in the flange thickness. There will be a variation in the flange thickness. If you look at this figure carefully, you will see that there will be a variation in the flange thickness. Okay. Now the flange thickness, obviously, when you should take in your calculation, you should consider one average thickness. So the average thickness TF that is written here. That is written here. This is the average thickness of the flange basically. This is 4.6 millimeter. Then thickness of the web, obviously when you will consider the web part, this is the vertical part, is the web part, so it will have a specific thickness. So in case of web part, generally the thickness is constant. Okay, from this particular part position to this particular location, the thickness is constant. After that, there is a change in the thickness or the dimension. So from this particular portion up to this limit, the thickness is constant, and that thickness is TW, which is given here as say 3 millimeter for the first section. Okay, now moment of inertia and radii of gyration, there is also a very important parameter. This is the XX axis for any section, beam section or column section, etc. When you will consider the cross-sectional view of the section, it may be a column, it may be a column cross section, it may be a beam cross section. So whether this one-dimensional member you will use for the purpose of construction of column or beam or any other member, that is not important. Important is that its cross-sectional area must have some standard dimensions. And XX axis is the major axis, okay, major principal axis, and YY axis is the minor principal axis. So about XS and about YY axis, what will be the moment of inertia that is given in this table for the first section is ISJB 150. It is this 322.1 centimeter to the power 4, 9.2 centimeter to the power 4, etc. And the radii of gyration, that means the radius of gyration about XX axis and radius of gyration about YY axis, these are also given. So these are some properties that is given for the first section given in this table. It is ISJB 150. Okay, 150 means it is the depth 150. Okay, now I will tell you the meaning of this designation, so that I will tell you, but just come to the next page here, then you will see that a similar kind of table is there. Similar kind of table is there. The section that you have considered, same for same section, designation is ISJB 150. Okay, same. But here, actually, in the next page, you will get the moduli of section, that means section modulus. About XX axis, what will be the section modulus? About YY axis, what will be the section modulus in centimeter cube? Okay, this is also in centimeter cube. Then the radius at root radius. What is root radius? If you look at this cross-sectional view, you will see that there will be a curvature. There will be a curvature here. There will be a curvature in the section. Okay, I can zoom it more. There will be a curvature here. Okay, this is the flange part. This is the web part. So at the junction of the flange and the web, there will be a curvature. And this is a circular curvature. And also here at the top portion, at the junction between the flange and the web, there will be a curvature. So this curvature obviously has the standard value. So radius of this circular part, it is written here as the radius at root. It is called the root radius. Root radius means it is basically a quarter circular curve. Okay, for this quarter circle must have one radius. So that radius is R1. Okay, and R2 is the radius at toe. Actually, this is the web. This is the flange part of the beam. It is called the root part. This particular part, where it has the junction between the web, it is called the root part. And this is the end of this flange, which is called the toe part. Okay. Now at the toe part also there is one curvature. Okay, there is a curved portion, and it is also having the quarter circular curvature. Okay. So for this quarter circular part, what should be the radius? That is also fixed here. Okay, so radius at toe, that is R2, that is basically the radius of this circular curve. Okay, that you are getting at the end of this free end of this flange. And radius at root means you are getting the curvilinear part here at the junction between the wave and the flange. So for that curvilinear part, what will be the radius of the curvature? It is R1. So these two, root radius and toe radius, you may require in your calculation. I am telling at this moment the radius at root, that means root radius will be considered number of times in your designing of beams. But toe radius at this moment we will not use. But if you require for some other purposes, that's why it is available here. If you want to use, you may do that. Okay, then some other parameters are also there. I am not entering into all this part because you have not studied the steel structure at this moment. Just this is the first class. Slope of the flange. Okay, there is a slope. You can see this one. That this is the slope of the flange. Okay, so that slope has a particular value, fixed value. For different sections, it will vary. But for a particular section, it should be a standard one. So this is 91.5 degree, etc. It is not 90 degree. It will be 91.5 degree, etc. Similarly, some connection details H1, H2, B1, C, G, etc. are there. Okay, we will tell you when we will discuss these things in the class. So these are different cross-sectional parameters. Okay, cross-sectional parameters. You will see some of the descriptions are given in this figure. So what is C, what is G1, etc., etc. This will be required for the purpose of connection. Say this is one beam and this is one column. They are connecting in this way. So for the purpose of connection, some other parametric details will be required, and that are given in this table. Actually, when you will consider this hard copy of this book, okay, then basically this is the left page. Okay, this is the left page. Page number is not written here. Let me tell you. This is, just a minute. This is page number 2. Okay, so this is page number 2. That is the page at the left side, and after that, this is page number 3. So when you will open the book, then basically this is the row of data for ISGB 150. It has started from this location. Okay, continuing in this line in the left page. After that, in the right page, it will continue in this way. There x, x, z, y, y, etc. It will end at this. Okay, so this is the complete set of data for ISJB 150. Similarly, the next one is ISGB 175. It will start at here. It will start at here. The second row, again in the right page. This is the second row, and it will end at 175. So I think if you when you will open the book, you will see this in this way. Okay. I don't know whether it can be shown in this way or not. It is the PDF file basically. That's why you are not getting the idea properly. But still, if I'm telling this one, the sum of the data are given in this page for all these sections. Okay, starting from ISJB 150 ending at ISMB 500. The same sections, for the same sections, some other data are given in the next page, ISJB 150 to ISMB 500. Now after that, this is the continuation of table 1. Here another are considered, that is ISMB 550 ending at ISHB 450. In the next page, that means the page at the right, the same set of cross sections, that means ISMB 550 to ISHB 450. These data are given here. Okay, so actually combining these two pages, you will get one set of data. Clear? So please, when you will take the data from this table of the handbook, you should be careful regarding this one. Now this is the I section. This is called normally I section. Now the designation is this one. For example, say what are the different designations you have seen? ISJB 150. Okay, and also ISLB 150. So ISJB 150 is, it has the depth. It has the depth of the section 150. ISLB 150, it has also the depth 150. But if you compare the width of the flange, thickness of the flange, thickness of the wave, you will see that it is 54.63. Okay, but here it is 86.8, 4.8. Okay, so they are having the same depth. ISJB has 150 depth, millimeter depth. ISLB 150 has also 150 millimeter depth. Okay, ISMB 150, that is also having 150 millimeter depth. Okay, but the other parameters will vary. That means the width of the flange, thickness of the flange, thickness of the wave, this will vary, and accordingly the cross-sectional properties vary. Now what is the meaning of this ISJB, ISLB, ISMB, ISWB? Okay, you will see the ISWB sections, ISHB sections. You may note it down if you have the copy of your draft book or exercise book, that ISJB, it is actually, the full form is Indian Standard Junior Beam Sections. Indian Standard Junior Beam Sections. Okay, ISLB means is the Indian standard light beam sections. Okay, ISJB, ISLB. Then ISMB has actually the name, it is a short form of Indian standard medium beam sections. Okay, then you will get ISWB. Okay, ISWB is Indian standard wide beam sections. Okay, and ISHB, it is the Indian standard heavy beam sections. So out of these 5 different sections, that means ISJB, ISLB, ISMB, ISHB, ISWB. Okay, out of this, actually, hello. ISLB is the Indian standard light beam section. ISJB is Indian standard junior beam section. ISLB is Indian standard light beam section, L for light. ISMB, M for medium, so Indian standard medium beam section. ISHB is Indian standard heavy beam section, and ISWB is Indian standard wide beam sections. Okay, if you just compare ISHB, ISWB 150. See, let us consider a fixed depth 150. Okay, all are having the same depth 150. Here it is also 150. Okay, but if you compare the cross-sectional properties, you will see that in case of light beam section, ISLB, for example, ISJB 150, it has this dimension. Now let us consider ISLB 150. It is having, instead of 50, it is 80. It is 4.6, 6.8. Instead of 3, it is 4.8. Now if you go to the ISMB 150, okay, you will see that ISLB 150 is having 86.8, 4.8. MB is 80 same. Okay, but it is 7.6, it is 4.8. So ISLB and ISMB having the same width of the flange. Okay, this is the width of the flange. Okay, width of the flange is same for ISLB 150. This is the width, and for ISMB 150, this is the width. So the widths are same, but the thickness of the flange and thickness of the wave, that will vary. It is 6.8, it is 7.6, it is 4.8, it is also 4.8. Okay, so some of the cross-sectional property will vary, mainly the thickness, and according to that, it is changing from ISLB section to ISMB section to ISHB sections. You just check ISHB 150. ISHB 150, it has the width of the flange which is equal to the depth of the section. So width of the flange is equal to the depth of the section. Obviously, it will be a heavy section, and also the thickness of the flange and thickness of the wave is more, so that's why it's the heavy section. Okay, and ISWB, when you will consider ISWB is also called the another section type, but it is wider beam sections. In this case, if you just compare the width of the flange and the flange, depth of the wave, basically depth of the section, if you compare, it is wider. So from that point of view, they have named in this way. But please remember and follow this instruction during the time of solving any problem, that at this moment all these sections are not available in the market. ISMB sections are mostly available in the market. So if you design one beam section, say with ISJB section or ISWB section, etc., that are not available. So ultimately, at the time of fabrication, at the time of construction, sections will not be available. So I am telling all of you to consider ISMB sections. If you think that the loads are very small, etc., span is very small, etc., you may go for ISLB sections, but never consider ISJB sections or ISWB sections or ISHB sections. These are not available in the market now. Okay, so whenever you will consider one designing of the beam or column or any the component of the structural component of the structure, steel structure, when you will choose the beam section, like this I sections basically. So when you will consider, you consider the M section, that is the medium beam section. So ISMB section you may consider for the purpose of designing. So these are the details for the I sections. that are generally used for the purpose of designing of the steel structures. Now, other than this one, just I'm telling, as this is the first class, you should know what are the possible cross-sectional types. Possible cross-sectional types. So this is one cross-section of one standard roll steel section. This is called the channel section. It is called the channel section. Channel section will have the cross-section shape like this. Obviously, there will be a length of the member. So the length is not standardized. The cross-sectional property of this channel section is standardized. So just like the beam section or I section, the channel sections are designated as ISJC. Look at this particular part. This is also similar type of table. It's a combined table. Combined table means it will be the table is written in two parts, in the left page and the right page. The left page is page number 6 and the right page is page number 7. So here ISJC, junior column section, junior channel section. Then it is ISMC, medium channel section, ISLC, light channel section. Okay, Indian standard light channel section. So here also the same thing. This is the continuation of the properties of the same set of sections, channel section. In the next page, you will get another type of the section that is called the angle sections. Okay, so regarding the channel sections, whatever I have told, that there may be different types, ISJC, ISLC, ISMC. Okay, there will not be any ISWC or HC, etc. Okay, so please consider this particular point. When you will do the designing of the steel structure. Now, other than this, actually, in case of designing of the beams, we generally use the I section. This is the roll steel sections, roll steel I sections, that is generally used for designing of the beams. Channel sections are also used. Okay, channel sections are also used, but other than these two, you will get the angle sections, standard angle sections. Angle sections are very common in different type of structural frame. It may be used in the factory shed. Okay, that means a truss-like structure. We use this angle sections. Okay, for the tie member, as a tie member, or say for the bracing member, we can use these angle sections. For the purpose of construction of even towers or bridges also, these particular sections are used, but they are used as a part of the compound section. I will tell you regarding the compound section in another class. Compound section means when number of standard roll steel sections are connected to each other by some connection system, and as a whole they will be considered as a single member. That's called the compound section. So angle sections are also used individually as well as it is used as a part of the compound section. So this is the angle section and it's called equal angle. Why equal angle? Angle section will have two legs. This is one leg, this is another leg. Now this leg and this leg, if they have the same cross-sectional shape, cross-sectional dimension, cross-sectional parameter, cross-sectional property, then if they are identical basically in all respect, then that is called the equal angle section. So this is the equal angle section that we may use for the purpose of designing of different component of the steel structure. So this is the equal angle section. In case of equal angle section, it is written in this way: Indian Standard Angle Section, ISA. In the other previous sections, we have considered ISMC, ISMB, like this one. Here it is Indian Standard Angle Section, ISA. Only one particular designation is used here, ISA. And 2020 means its leg size. That means this is the A dimension, this is the B dimension. So A and B both are having the same length, 20 millimeter. So ISA 2020 means it will having the same leg dimension, that is 20 millimeter as well as 20 millimeter. It will be 25, again it will be 25 because it is an equal angle section. So Indian Standard Angle Section 25, 25, Indian Standard Angle Section 30, 30, etc. So these are the standard sections. This is the continuous table. This is in page number 8 and this is in page number 9. That means the left page and the right page of the book. So this is up to ISA 65, 65. Then you will get 70, 70 up to 200 by 200. Okay. Again at the right page, the same continuation is there up to this one. After that, After that, after ISA 200 means both the leg size are 200 millimeter each. Okay, after that, there will be the unequal sections. In case of unequal sections, basically the properties are required for this longer side as well as for the shorter side. So here the longer dimension is marked as A dimension and the shorter dimension is marked as the B dimension. So ISA 30-20 means the larger leg size is having the width 30 millimeter and the shorter leg width will be marked as or will be given as 20 millimeter. So 30 millimeter by 20 millimeter will be the size of this unequal section. Okay, just I'm telling you what are the possible sections that you may use for the designing of the structural steel.
স্যার এখানে প্রত্যেকটা জায়গায় রোলড স্টিল সেকশন লেখা রোলড মানেটা কি এখানে?
Rolled one it is basically the way of preparing the standard section. Okay, rolling, it is prepared in the rolling mill. The sheet is basically rolled to form this particular cross-sectional shape. So it is prepared in the rolling mill, and the process of manufacturing is the rolling process. That's why it is named as the roll steel section. Okay, if you want to know regarding the process of making these sections, then I will try to give you some additional information in another class. So, and you may also search in the net, you will get some detailed information regarding this process. Also, you may go through the textbook where some picture or the diagram may be there regarding the manufacturing process, etc. So this is regarding the manufacturing process. The roll word is used from that idea. So this is the roll steel unequal angle section, and you may note that here the designation is written in this way: ISA 40-25, 45-30, 50-30, like that. Okay, so 50 is the larger leg width, and 30 millimeter is the smaller leg width. So in this way, these details are there for different unequal sections. So these are the unequal sections, 200 by 150. That is probably the last one. Then some other sections are there. This is the bulb angle, etc. We generally do not use this one. So actually this particular handbook, if you just go to the first page, you will see that it is the book. It has first issued in the year 1964. Obviously after that, though it is reaffirmed in 2003, that means the cross-sectional properties that you are getting from this handbook that are also valid at this moment. But please remember that two things you should remember. First of all, some sections are there in this handbook that are nowadays not available in the market. We are not using in the designing of the steel structure. So some of them are there. And another important point is that other than these standard sections, okay, some other steel sections are being prepared by different steel manufacturing company, structural steel manufacturing company. So you will get the cross-sectional, standard cross-sectional dimension for those sections from the documents or from the manufacturer's document. You will get the cross-sectional property for those sections. Okay, for example, Tata has prepared some another standard sections. So if you want to get the property of those sections, you should go to the literature issued by that manufacturing company. So when you will use that, you must consult that particular details given in that literature, which is not available in this handbook. So some of the sections given in this handbook are not available at this moment, but other part that are available at this moment, those data you can use from the section handbook. Okay, and you should also remember that some other cross-sectional standard cross-sections are being prepared by different manufacturing company nowadays. So if you want to use that, you should consult the published literature from them. Okay, now these are the different parts of this SP61. I will not enter into all these parts at this moment. So what are the different types of sections that are generally used? I am giving you the idea regarding this one. So this is the angle section, I sections, then the angle section, etc.
Sir, can you please give the sections which are commonly used mentioned before?
in case of beam sections, when you will design the beam, okay, you will use the ISMB sections. Okay, the medium beam sections always you use. I will, in my part, I will tell you the procedure of designing of the beams and columns. There I will suggest you to use the ISMB sections in case of I section. In case of channel section, ISMC sections. Okay, if you want to use the angle sections, all these angle sections, because there is no such variation, only ISS sections are there. So any ISS section you may use. And obviously, when Professor Swaraj Mandal will discuss the procedure of designing of the axial load member, that is a compression member, tension member, etc., he will use these sections mainly, the angle sections. Okay. In my part, the requirement of the angle section is not so much. Still, if I use, then I will refer this particular these tables. So bulk sections you may not consider at this moment. Okay. The T bars, these are also nowadays available. So the T sections sometimes we use, but as a flexural member, I will tell you in my following classes, that what are the sections that we generally use as the beam section. T sections are also used, mainly T sections are used for the purpose of strengthening some components, steel structural component, say for the purpose of stiffener, etc. We can use this T section mainly. Okay, some other cases also these are used, but these are also standard sections. It has standard properties. So when we will require this type of sections, we will tell you which section you may use at this moment. Okay, now other than I section, channel section, T section, angle section, you may have to use some standard plates. Okay, now plate, when you will consider, plate is a two-dimensional object, and it has no such cross-sectional parameters. So much cross-sectional parameters are not there. Only the length and the width is important, and accordingly what is the area of, etc., that you may get from this one. So the standard widths are 900, 1000, 1100, like that. So these are the standard plates, okay, that you may use for the purpose of the construction in steel structure. Now here the thicknesses are also standard. If you want to consider in thickness, say 5.5, it will not be available. So it is the 5 millimeter plate. Then there will be the 6 millimeter plate. Like the plate thickness are also fixed. 8 millimeter plate, okay, 10 millimeter plate, 12 millimeter plate. So plates, when you will use for the purpose of construction of steel structure, say as a gusset plate you are using. So gusset plate will connect one steel member to another steel member. So that plate thickness should be the standard. For example, say after 12 millimeter, it is 14 millimeter. So if you want to use 13 millimeter thick plate, that is not available in the market. That is not the standard plate. So that cannot be used. So these are the different thicknesses of the plates. Now I will tell you, I will show you another particular part that is called flat. Okay, plate and the flat, this is not same. This is the plate of 63 millimeter thickness. Okay, so sheet and strips, these are also there, but flat section is very useful thing. We may use this one in the designing of the connection between the compound sections. So sheet and strips, okay, it is there, but it is also, this is a mild steel flat. So flat means, in case of flat, its cross-sectional area is a rectangular one. Okay, just you consider one wooden scale, for example, say, okay, wooden scale or ruler, if you consider. So it has a specific cross-section. What is the cross-section? It may not be the exactly rectangular, but let us consider, for in our case, the flat means it's the rectangular section. Cross-section is exactly rectangle. Now the rectangle will have a width. So this is the width, 3, 4, 5, 6, 8, 10, 12. These are the width. This is the, sorry, these are the thickness. This is the thickness, 3 millimeter, 4 millimeter, 5 millimeter, 10 millimeter, 12 millimeter, these are the thickness. And the flat will have a particular standard width also. So just think about one dimensional member. The cross-section of the member is a rectangle. The rectangle is having the width 10, 15, 20, 25, 35, etc., etc., and its thickness, and its thickness will be 3 millimeter, 4 millimeter, 5 millimeter. These flats are also used for some purposes in the steel structure. So you should remember this one. The flats may be required to be used in different steel design part. Okay, different steps of steel design. Now the bars are there, some other things are there. I am not entering into the entire SP6 handbook at this moment. I am just giving you some idea from which you will be able to understand that how the steel sections are used in the construction of steel structure. Okay, here some economy in the steel beams, etc. channel, that is the flexural limits from section moduli, some modulus of section, etc. What is the shear carrying capacity? These are given. This particular table we will not use because when this code has been prepared, the working stress method is a process of design that was followed. So at this moment, in the this particular revision of IS 800, you will see mainly the limit state method of design has been used. The working stress method of design is there, but emphasis has been given to use the to follow the limit state method of design. I will discuss that one in our following classes. So when you will consider this present way of design, that means the method of design, obviously this data will not be very useful. But here another particular page I am trying to show you. Just a minute. Actually, compound section. What is compound section? Compound section means number of standard roll steel sections. They are used. They are combined, and ultimately they will be used as a single member. I have mentioned here one is called the plated beam. Plated beam means some plate elements are connected to the flanges of the beam. That picture I am sharing with you. This is the I section. This is the I section. Actually, why I am sharing this book, actually, if I want to draw this one, it will take time. But some of the pictures are there in the handbook. So from this handbook, you will get not only the idea of this shape of the section, as well as what are the different properties that are given for those sections that are also available in this handbook. So you will get the idea. So this is the plates, additional plates, single joist with additional plates on both flanges. Okay, to be used as girder. When we will use this particular section as a girder, and if the load carrying capacity requirement is very high, then the standard section will not be able to carry that. So in that case, we can attach some additional plate. We can attach some additional plate with the flanges of the beam. Okay, flanges of the I section. So if you attach these two, obviously what will happen? The moment carrying capacity, the load carrying capacity of this section will be higher than the previous one. So this is the way by which one compound section can. It is one compound section. It is a compound section in a sense that plate is one structural component, I section is another structural component. Now the plate will be connected with the I section either with the bolt connection or with the weld connection, but ultimately it will act as a single member. So this is the compound section that we generally use. I will tell you regarding this particular part in my class when this will be. There will be the requirement of using this one. Now, other than this one, let me show you some other things. For example, here, this is if the load carrying capacity requirement is too high, that means the single roll steel section is not sufficient to carry that. Even by attaching two plate with the two flanges, it is not suitable to carry the external load. So in that case, some other standard section which is available in the market. For example, for the channel section, this channel section is attached with this flange part. That means this is the actual flange of the I section. Over that there is a plate. Over that there will be a channel section. Okay, so these are the possible way of creating the compound section. Okay, now what we will use and what we will not use regarding that. Obviously, some discussions are needed that I will tell you afterwards. At this moment, I am not entering into that part. Just I'm showing the arrangements. So this is one arrangement where one plate is attached with the bottom flange of the I section, but with the top flange, one channel section is attached in this way. So this is also a plated girder. It is not the plate girder actually. It is a plated beam. Plate girder is a different thing. Plate girder is a different thing when it will be in the syllabus of the next designer metal structure, where you will see that plate girder means it is a single plate, the wave is a single plate, the flange is another plate, and they will be connected to each other either using the bolt connection or the weld connection. That is for the plate girder. But at this moment, we are considering the standard rolled steel beam sections, but its strength is enhanced by connecting some standard, additional standard sections with it. Okay, so these are the one way of preparing the compound section, etc. So another thing that I am trying to show you, it is available in SP6, and obviously in this case, depending on the plate thickness, depending on the top flange in case of channel, in case of plate, obviously when you will use different sections, so different cross-sectional property will change, and those changed cross-sectional properties are given here. So this is also one way of doing. This is also another combination. Okay, this is one channel, this is another channel. They are combined in this way. Okay, so if you just go through the different pages of SP6, you will get the idea how the compound section can be prepared. And it is the table where just if two plates are attached with the standard section, okay, what will be the moment of inertia contributed by these two plates? The moment of inertia contributed by the standard I sections that are already available in the first table. So if you just add two flange plates, if you attach with the flanges, then how much moment of inertia it will contribute? So that is given there, and depending between the gap between the two plates, the moment of inertia will increase. So if you increase the height, or if you increase the distance between these two plates, the moment of inertia will be more. But when you are attaching this one with say ISMB say 500, then the gap between these two plates is 500. When you will attach these two with ISMB 600, then the gap between these two plates will be 600. So accordingly, the moment of inertia contributed by these two plates that are written here. Okay, so this is basically the wave plate. If you use single, for example, say you are trying to prepare one plate girder. For example, say there is no I section here, just you are considering two flanges, okay, by these two plates, then moment of inertia contributed by this one you can calculate. And if you just use one wave plate, then what will be the moment of inertia contributed by this wave plate that are additionally given here. Okay, so wave girder may be considered in this way. This is also the plate and angle girders. Here the plate is there. This is one single plate. Just now I have told you that the flange plate may be considered separately, the wave plate may be considered separately. So that will be a plate girder. But to enhance its load carrying capacity, to strengthen the wave, what we can do, wave and flange, what we can do, we can attach some angle in this way. So that is also one way of preparing some compound sections. So these are generally used for the purpose of beam sections. Other than this one, let me show you this particular part. There are different tables having this different cross-sectional properties. Just let me tell you this one. Yes, the properties of two angles back to back. When you will consider two properties, it will be required when you will design the truss. I think SMSR will discuss that particular part. So when you will consider two angles back to back, okay, it may happen that instead of considering one angle section if the load is too high, we have to use double angle in the designing of the members of the truss. So when you will consider this, obviously the gusset plate which will connect these two angle section, that will be in between these two. Okay, so this is the position of the gusset plate. There will be a plate in between these two. So depending on the plate thickness, obviously what will be the moment of inertia about x axis, about y axis, that are given here. Okay, so these are the compound channels, angle sections. Okay, or you can see the double angle sections, which are very common. Double angle sections are very common in the truss. This is an unequal section. Okay, long angle back to back. You may arrange it in another way, that means a short angle back to back. But here it is a long angle back to back, which is more common. Now this is the short angle back to back. Okay, so these are the standard sections and its compound form that we generally use for the purpose of designing of the steel structural component. Similarly, here some other connection types are there. I'm not entering into that part. Now you will see that how the other arrangements can be done to connect two members. So this is one combination, is called the starred angles. Okay, this is one combination. Then let me show you this safe load, etc., that we will not consider because we will follow the limit state method of design. So safe load calculated based on the working stress method of design, etc., that will not be useful to us. So we will design it according to the limit state method of design, and corresponding to that, what will be the load carrying capacity, that we will discuss. Okay, so let me show you. This is also one arrangement. You may form one beam section in this way, okay, or the start section in this way. They will be connected in the 4 angles are connected in this way. Okay. So these are the different cross-sectional shapes. The important point that you should remember is that in case of reinforced concrete design, when you have designed a reinforced concrete rectangular beam section, you have chosen the depth of the beam, the width of the beam as per your choice. Okay, just you have considered that the width is say 275 millimeter, depth is say 425 millimeter. You have considered that. If it is 430, if it is 432, there will not be any problem in designing that. Actually, you may give any cross-sectional dimension in that case. And when you will design the steel structure, you must remember that there are some standard steel sections that you have to use. There is no scope to give any arbitrary thickness or arbitrary width of any section. So some standard sections are there, and you have to use that. So if the section A, for example, say section A you have taken and you have checked, say the section A is failing, then automatically you should consider another section, say section B, and you have to check whether section B is, obviously it is higher than section A, whether it is safe or not. If section B fails, then you have to consider section C, like that. So in this way, gradually you should check whether which section will be the safe section. So that is a trial and error process in case of steel structure. So obviously design means a trial and error process, but in case of steel structure, the more trials may be required to reach the optimum section. Now this is a particular page. This is page number 168. You must remember this page. Page number 168. That will be very important. You will require this one number of steps. This is the rivet gauge distance in the legs of the angle. For example, say this is the angle section. Now when you will do the riveting, or you will put the bolts, so there are specific location of the bolt line or rivet line. Okay, if you want to provide single bolt, okay, then the distance, what will be the distance? Distance is C. C distance is a single row of rivets that are given here for different leg size of the angles. Leg size is starting from 20, leg size is ending at 200. For each leg size, okay, that means ISA 200 something is there, ISA 20 something is there. So for those section, what should be the position of the rivet or bolt? That is fixed by the IS code here. This is the location of the row of rivet or bolt measured from this corner. But if 2 rows or 2 bolts are there, then first distance is A and the second distance is B, that A and B are given for sum of the leg sizes. So if the leg size is too small, then 2 rows of rivets or bolts cannot be accommodated. So A and B are given only for few leg dimensions, starting from 100 millimeter ending at 200 millimeter. For that, you may accommodate 2 rows of rivets or bolts, and for that one, what will be the A dimension and B dimension that are given here. And another important point is that if the maximum rivet size, okay, for double row of rivets, if you use the double row of rivets, then obviously A and B, if the locations, then what will be the maximum rivet size or bolt size, that is given here. So that is given for the leg size 100 millimeter to 200 millimeter. Because if the leg size is lower than that, then there is no scope to provide 2 rows of bolts or rivets, and in that case only 1 bolt will be provided, and there is no such restriction regarding the maximum rivet size, because as there are 2 rows of bolts and rivets side by side, so if the dimension is more, then there will be a problem to do the bolting or riveting. That's why this restriction of regarding the maximum rivet size, etc., these are given. So I have given you the basic idea regarding the what are the structural sections that we may use, standard sections that may use for the purpose of designing of the steel structure. So that I have given you, that I have shown you from the handbook SP6. Okay, you have at least got the idea what are the possible cross-sectional shapes of beams and columns. This is a very important cross-section, though it is 12-2, you have another class. So just I'm telling, this is a compound column. This is a compound column section, generally used in this way. So this is one I section, another I section. They will be connected by either battened or laced. This is the laced or battened. That connection I will discuss in the class. So this is the formation of the compound section. Okay, compound column section. These are the standard sections. This I section is a standard section. This is another I section is a standard sections, and they will be connected to each other through some connection system, and that is called the lacing connection or a batten connection. So lacing connection, batten connection, I will tell you in the designing of the column class. But at this moment, you just remember that 2 I section, 2 channel section, they will be combined to form the compound sections of the column. Okay, compound column is the part of the syllabus. So that compound column may be formed in this way. So this is the combination of I sections. Just I am showing that there may be the combination of channel section also. Okay, this is the combination of channel section back to back. Okay, it may be toe to toe, front to front, it may be there, but it is a back to back. So this is the compound column section that also we should try to discuss. We will try to discuss in this particular class. In the following classes, we will discuss different topics. So one of the topic may be the compound column. How to design the compound column, that we will discuss. This is one combination where 2 channel sections are placed in this way. Okay, they are connected to each other directly. So this is also one option. So I think you have got at least some idea regarding the possible cross-sectional shapes of standard steel sections and how they are prepared, etc., and how the cross-sectional property of that you can obtain from the Structural Engineer's Handbook number 1, SP61. That idea you have got partially, obviously, but still I have tried to share with you this particular information. So in the next class onwards, that means in the next Tuesday, actually I will not be there to take the class in the next Tuesday. I will make some arrangement such that I can take one class on another timing. So I will tell you, I will inform you. But from the next class onwards, I will start designing this particular part. This is the designing of the lateral restrained and unrestrained steel beam. This particular part I will start with the help of the IS 800 code, how it can be designed, that I will start. So let us come to the end of the class today. Obviously, some of you have joined late, so I will try to record their attendance. So if you have any query or confusion, obviously you may ask. Otherwise, we will come to the class at this moment. Come to the end of this class at this moment. Okay, let me stop the recording.